This video is about functions with a view to solving unknown coefficients. There's a couple of things to remember before we start looking at examples in this video. First of all, remember that a point can be called a couple. A point is made up of an x value and a y value. The x value always comes first in the point, and it's the input. The y value always comes last in the point, and it's the output. Remember, the words point and couple can be used interchangeably. They both mean the same thing. So here's our first example. We're told that f of x is ax plus 5. We're told that 2, 11 is a couple of this function, and we're asked to find a. So remember what this couple actually means. It means that if I put 2 in, I get 11 out. So let's put 2 into this function and see what that looks like. When I'm putting 2 in, I can write it as f of 2. I replace the x in the function with this number 2 in brackets. And I know, because I'm told the couple, that the output or the result must be 11. This gives me an equation that I can solve to get a. First, I'll do a little bit of tidying up. A by 2 is 2a. Then I'll get the 2a term by itself. When I subtract, I get 2a equals 6. I'll divide 6 by 2, so a is equal to 3. And this is the solution for the question. Here's a second example. 1, 6 is a point on g of x equals x squared plus bx plus 2. Find b. Remember that when the 1 goes in, the 6 comes out. So I'm going to put 1 into the function, and I'll write this as g of 1. And that means replacing all the x's with 1's in brackets. I know that 6 is the output, so I should let this equal to 6. And now I'll tidy this equation up a little bit and solve it to get b. So I have 1 plus b plus 2 equals 6. I can add the 1 and the 2, so b plus 3 equals 6, and then I'll just get b by itself. So b equals to 3 is my solution for this question. Okay, now we're going to look at example 3. So example 3 has a diagram to go with it, and the diagram is just showing you 2 points. Now the points we'll treat exactly like in the previous examples. The first value is the x, the input. The second value is the y, the output. The 2 points are 0, 3 and 2, 1. Now just like before, I have a function. I don't know an awful lot in this function, but that's fine. I'll still put my input in and get my output out. And because I have 2 points, I'll do it twice. So I'm going to start at the point 0, 3. So I'm going to put 0 in to my function. That's a times 0 plus b. And that will be equal to my output, which is 3. And now I want to tidy this up a little bit, and maybe I'll be able to solve, or maybe I'll be able to just tidy up. We'll see what happens. Well, if I look at a by 0, that means I have a 0 times. That means I have no a's, so that's gone. So I'm left with b equals 3. So actually I've got a solution now for b. I know that b equals 3. Okay, that's all I can do at the first point 0, 3. So I'm going to go on now and use my second point, the point 2, 1. That means I'm going to put 2 into my function, so f of 2. So I'm replacing my x with 2, a times 2 plus b, and I'll let it equal to 1 because 1 is the output for that point. And I can tidy this up a little bit to 2a plus b equals 1. But actually, hang on a second, because we solved for b earlier in the question. So I now know that b equals to 3. So where I see a b in this equation, I can replace it with the number 3. Now I have an equation that I can solve for a. I'll bring the 3 across and subtract. So 2a equals to negative 2. I'll bring the 2 in front of the a across and divide. And now I have a result for a as well. A equals to negative 1. So I've solved this question because it asked me to find values for a and b. And we have a value for a and we have a value for b, so we're finished. Let's look at one more example. So this example says that g of x equals x squared plus bx plus c, and this defines a quadratic function. Think for a moment what a quadratic looks like. 110 and 218 are on this function. Find b and c. Sometimes with questions like this, they may give you the question slightly differently, in that they may tell you the function gx equals x squared plus bx plus c, but they may show you a diagram with the 2 points marked on instead of writing down sentences to describe it. The diagram might look something like this. Whether you're given a diagram or a written question, the approach is exactly the same. And it's just like what we've been doing all along. We put in our first value from the point, our input, and we let the result equal to the last number in the point, the output. So I'm going to start with the point 110. So I'm going to put 1 into the function, and that means that I replace all the x's with 1. And at the end, I'll write equals 10 because that is the output that I have when I use an input of 1. Now I'd like to tidy this up a little bit. So I've got 1 plus b plus c equals 10. There's not an awful lot more that I can do with this. I can't solve for b and c just yet, so I'm going to leave it exactly as it is. And I'm going to move on to my second point. My second point is 218, so I'm going to use an input of 2. That means replace all the x's with 2. And of course my result this time is going to be 18 because that's the output. Again, I'd like to tidy this up a little bit. So that'll give me 4 plus 2b plus c equals 18. Now, individually, either of these equations by themselves aren't going to allow me to work out b and c. There's just not enough information in them when I look at them one at a time. However, I've got 2 of them to work with. Can you remember what type of equation that is when I've got 2 equations and there are 2 unknowns? It's simultaneous equations. So I'm going to need to use simultaneous equations to solve to find b and c. So I'm going to write down my 2 equations again, one below the other. And remember, in simultaneous equations, I want to remove one of the variables so that I can solve for the other. In this type of question with functions, the easiest one to remove is generally the c. I've got plus c and I've got plus c. In order to remove the c's, one of those must be a negative. So I'm going to multiply my first equation by -1. This is going to give me -1 minus b minus c equals -10. I'm going to write my other simultaneous equation directly below it without making any changes to it. Now I'm going to look at these 2 equations together and see what I can cancel out. Well, plus c minus c makes 0, so I can cancel out the c's, and then I'm going to squish the 2 equations together to make one equation. So how is that going to look? Well, -1 plus 4 is going to give me 3. Minus b, or minus 1b, plus 2b is going to give me plus 1b. Remember, I can write 1b as just b. The c's are gone, and on the right-hand side, minus 10 plus 18 is 8. Now it's easy to solve for b. b is 8 minus 3, so b is 5. So I have my solution for b. I still need, though, to get my answer for c. It's really easy to do that by just taking my answer for b and putting it into either one of my original equations. Pick whichever one you think looks a little bit easier. I reckon the first one looks nice and straightforward. So I'm going to replace the b in this equation with a 5. And now I can solve this equation quite simply for c. I'll start by adding 1 and 5 to make 6. I'll bring the 6 across and subtract, and then I'll complete my subtraction and get 4. So my solution for c is 4. I've now found the values of b and c as requested in the question.